Hey everyone, and welcome to AWS Cloud Security Lab series. Today we are diving deep into one of the fundamental pillars of cloud security groups. In this lab, we will focus on to control network traffic in our virtual private cloud or the VPC. We will be working through AWS Cloud Security Lab 4.1, securing VPC resources by using security groups. To perform this lab, we have to initialize the lab environment. So for that, we have to go to module 4. In the module 4, there is lab 4.1, securing VPC resources by using security groups. And from here, start the lab. Actually, we need to initiate the lab because it takes around 1 to 2 minutes to initialize. Start lab. And in this, we are having 8 tasks to perform, which are comprising 38 activities. So the objective of this lab is to examine security groups to determine what traffic is allowed, change which security groups are applied to EC2 instances, create new security groups, update the inbound rules on security groups to follow the principles of least privilege, understand how security groups can reference other security groups, and also we will go for the ACL's access control list to block traffic on a specific TCP port and connect to an instance in a private subnet by using SSH. And actually, last two objectives are related to the SSH, means that a black screen, the command line, and connect to the instance in a private subnet by using AWS System Manager, Session Manager. So it is taking some time to initialize because private virtual environment is going to be created for each person. The time allocated for this lab is 3 hours, but this lab should be completed in 90 minutes. But obviously, if we do it in more with more concentration and all, so it may take less than that also, right? So the scenario is there is AWS cloud environment. In that cloud environment, we have lab VPC, and then in the lab VPC, IP addresses are allocated in public subnet and the private subnet. And we have to secure the application server that is installed there. So the first step is to start lab, and then we have to wait until this AWS button is going to be green. Okay, so let's have some other things to discuss. So what are the security groups? Basically, think of them as virtual firewalls for your EC2 instances. They operate at the instance level, controlling both inbound and outbound traffic. Then there are network ACL's access control list, which work at the subnet level. Security groups are at the state. The stateful means that they follow the state of the input and the output data, right? Traffic actually. This means that if you allow inbound traffic, the corresponding outbound traffic is automatically allowed. They work on a deny by default principle, so you must explicitly allow traffic. In this lab, we will be basic web server in our VPC and then configure security groups to control access to it. We will be focusing on how to allow HTTP traffic while blocking all other unwanted connections. We will show you how to create, modify, and test security groups and the rules. The lab, as we are waiting for the lab session to start, let's see some other things that are here. So, so this AWS button is green, so we have to click on that. So we will get access to the virtual machine and the lab environment. So here in the task 3, we see that in the management console, search for the VPC to open. So we have to open the VPC. Okay, VPC. So virtual private cloud configurations are in front of us. Here we can see that analyze the lab VPC and the subnet configuration in it. So in the navigation pane, choose your VPC and the AWS region that you are currently observing two VPCs. One is in the default VPC, which is a CIDR range of 172.31.0.0 over 16, whereas lab another one is lab VPC, right? So let's see, there are two VPCs available here in our region. So that is lab VPC and another VPC is created. Here we can see IP CIDR is 172.31.0.0/16. So it means that there are 65 plus thousand IPs are able to access this IP, and same here, right? So in the subnet list, choose the VPC column header, and then we can see that there are subnets are available here. We can see public subnet A and public subnet B. These are some public subnets that are affiliated with the lab VPC, right? So unique CIDR ranges are also there. Next, analyze the routing details of I2 EC2 instances in the private subnet and change the name to the root table. Select the checkbox for the private subnet, and then in the lower pane choose the root table. So private subnet, we have this private subnet, and here in the root table we can see that there is this root table available. So what is the task we need to perform? And we have root table tab. Above the list to choose the link of the root table to assist it with this subnet, choose the root tab. Here we can see that the root table, and then there is another option. Next thing that is, notice that all IP addresses in the lab VPC are in this way and will be routed to NAT gateway. NAT gateway for network access, right? That is network address translator, basically from private network to public network to access the resources, right? So come to the next point, that is tag. Choose the tags tab and then choose manage tags. So these are the tags, and from here we can manage the tags. So here we can see that Cloud Lab is this one, whereas name is basically there is no one. That is a private subnet. So next thing that is we have to change the name of the root table from change name to private. So this one, copy this one, and then root table, and then this one in here we have to change the to private. So we are going to make it private. So next thing that is choose the root tab and then choose NAT, which is a target for non-local traffic tab, and this is for that, this will be used for the network traffic, right? So this will be selected. This configuration will allow us to uh, access the resources that are privately that are privately private, that were private previously, and now that will be able we will be able to access using the NAT, right? So this diagram is showing that using this one, using NAT gateway 10.0.1.0 over 24, we are going to access this private subnet now. So, okay. Observe detail about the app server EC2 instance, which is a private subnet and it's associated with security group. So we have to focus on the EC2 instance. So let's go to here and access the EC2. Here we can see there are three instances that are running: proxy server 1, app server, and proxy server 2. Means that two proxy servers are working and one app server is running here. So at the moment, we can see that the app servers, like the app server instance, and go to the detail and see its IP addresses. App server and go to its. So in here, if we go to app server detail tab, this one and then detail tab, here we can see that the instance ID instance is running, a private IP is here, there is no public IP address this there, and then there is IAM role, and all the information is given here in the details. Now switch to the security tab. Here we security group is associated with that, which is app server SG. Here you can see the name, and their inbound rules and outbound rules are defined. Inbound rules means that there is security group associated, and then there is port 80 and TCP, and from anywhere then the data can come. And outbound rule, the data can go to from any destination, right? So uh, all things has been seen here, right? And now next task is choose inbound rules, and notice that rules has been not denied for defined for HTTP traffic, and also these are the rules. We already saw these two things, right? Choose the outbound tab. Notice that outbound traffic is allowed, and this is default setting for security groups. So here we can see it, right? Inbound rules and outbound rules are defined here. So now come to the next point, that is analyze the public subnet resource settings now. So in the Amazon VPC console, analyze the routing detail that affect EC2 instances in public subnet A. Now we have to duplicate this environment and open an PC console also in front of us, because we need to switch from one to another one. Means that one tab is for the instances, another one is for the tab for the VPCs. So for the VPC, we are here that we are having two VPCs. So in here in VPC tool, we need to go to the root tables. Here we have we need to go to subnets, and then we have to access the public subnet A, and in here we have to go to its root table here, and then notice that public subnet is 000, means anything, and then choose the IGW link, which is target to the local traffic, this one. And then on the detail tab, notice that the internal gateway is associated with the lab VPC. It is related to the lab VPC. VPC ID is like this. So it means that this gateway is associated with the lab VPC. So now observe detail about the proxy server 1 instance, which is running on public subnet A, and it is associated with security group. So in the navigation pane, choose instances, and then let's select the proxy server 1. So here in this proxy server 1, we came to the EC2 instances and choose this one, proxy server 1. In this proxy server 1, go to the details, and then we have to see its security tabs, and we have to see that which security is there. So security tab, and here we can see that proxy SG is attached to this instance. So proxy, you can see the inbound outbound rules defined for this one, right? So next thing, So the same we have to check for the proxy server 2. Click here, see that security group, and here we can see proxy SG. Security group 2 is associated with proxy server 2, and also there is no inbound rule attached, and the one outbound rule is associated. So this is the difference between inbound and the outbound rules. In proxy server 1, we have seen that there was inbound and outbound rule, but in proxy server 2 there is no outbound rule, right? So in here we have to create a new inbound security rule. So how? So click on this security group 2. Here we can see that edit inbound rule. So click on that, and then we have to add the rule. And in here, let's see what are the rule inbound rule. Choose edit and then add rule. Type is choose HTTP, and then source is anywhere IP4. HTTP anywhere IP4, and anything else is required. No, and choose save rule. So we have to save the rule. So the rule has been saved now. So now next point, that is testing HTTP connectivity. Now we have created and we have connected the IP. We have configured these security groups, and now we have to test that there is one server running on our EC2 instance, that is app server. So in that app server is working or not. So we have to test it. So in that case, Amazon EC2 console instances, proxy server 1 instance, and then select the and then uh, to see it is working or not. So we have to select the proxy server 1, and then in the detail, there is public IP address. Copy this public IP address and what is required, and paste in the browser to see it is working or not. So let's check it. Yeah, it is connected with the application server. So hello from the web server running on the instance. So the connection is established here. So next thing, use the same method for the proxy server 2. So let's check for this one, proxy server 2, and then public IP, this one, and just paste it here and see that how it is behaving. It is also hello from the web server running on the app server instance, means that uh, that app server is accessible from these two proxy servers. So the task is completed. Close both tabs where the application server running, and everything is fine now. So close these ones. So now come to the task 4, that is restricting HTTP access by using an IP address. Proxy servers are working for the app server, but now we are going to restrict one through which we will not be able to access the application server. So for that, so now, according to this activity 14, we have to find out the proxy server one's private IP addresses. That is going to start from 10.0.1, which is here. When we'll click this one, in the detail, there is private IP of DNS, name IP4 only. So that is this one or this one. Yeah, this one is here. So we have copied this one, and now we have to configure app server security group. So the next step is edit the application server as security group inbound rule. So how we have to go there, uh, choose the security group, and then directly we can come from this way. For example, Okay. From here, like left pan instances, images, elastic, block store, and secure network and security groups. So in here we have application server security group. So we have to click on that. Here we will have their inbound and outbound rules. So inbound rule, which rule we are going to change? That is edit inbound rule, and then we have to choose delete the all traffic 000, and then we next paste the IP address that is only relevant to us, and add pasting at 32 end of the IP address. So only that IP address will be allowed to do the things. So I edit inbound rule, and in here we are going to add this one, uh, and after that we have to add the CEDAR value that is 32. So only this IP address will be allowed to do anything, right? So we have modified the rule now. Then save rule and move further. Okay, so here we can see now it is 10.0.1.13/32 only instead of 000, mean all traffic, instead of all traffic only this certain IP will be allowed to do, right? And you have now updated secure proxy server 1, only allow TCP port traffic from proxy server 1 only, right? And then now test the this the functionality of proxy servers now, because we have modified the rule. So go to the public IPs of both instances again and see how it is behaving. So EC2 instances, and then see the IP address is here, that is copy, open this one. This is for the proxy server 1, and when we go and check for the second instance from the proxy server 2, see its IP and then try to connect with it, then we can see that it is trying to connect. It is taking some time, and in the end it will not be able to connect. Let's see what is the response here. Okay, it is waiting. So it means that there is no response from the server. The site can't be reached. So so that allow a security group inbound rule allowed proxy server 1 but denied all other traffic. So the task is completed here. Now come to the task number 5, that is scaling restricted HTTP access by referencing a security group. For that, we are deciding to turn proxy server 2 into another proxy host to create redundancy. Means that instead of applying security group for each proxy server, we want a big proxy server here. So for that, uh, now we will look at the security group assigned to the proxy server 2 host. We can reference to the proxy server proxy security group as the incoming source of HTTP connections to the application server. This means that any instance that is assigned the proxy security group will be granted permission to the HTTP traffic over the port 80. So instead of every security on each instance, we are grouping and making some more bigger perspective of the security group, proxy security group, and we are making the inbound. We are applying the inbound rules up there. So for that, we have to modify app server service group, security group inbound rule once more, so that the allowed source for HTTP traffic is proxy SG security group instead of the proxy server 1. So that currently the traffic is coming from the proxy server 1 or proxy server 2, but now we are enabling that traffic using the proxy server group SG security group. So for that we have to go to the security groups, and then we have to modify the app server security group, And here we will add the rule, choose HTTP custom, and then the source field, enter the SG, where when the drop down list there will be proxy SG security group, and we will save the rule, so that in the app server, rather than we are going to use proxy server 1 or 2 separately, we are applying a bigger proxy uh, security group here, right? So let's start and come to the point, that is security groups, and then we have to go to the app server security group. So security group that are here, and then app server security group there, that is here. Okay, in here we have to modify the inbound rule, edit inbound rule. So we just configured this one, and now we are making it a bit bigger perspective, right? So for that, choose the HTTP custom, and then in the source field enter the security group rather than the simple IP custom. And here we have SG security group, and from here we will use which security group. There are proxy SG, proxy SG2, server SG, right? So from here we have said that we have to choose proxy SG security group, right? So proxy SG, this is the group. Here we can see the name proxy SG, right? And save the rule. So in here again we can see that that is the previous one, and then we have to add the rule, and then that is HTTP, and it is SG. We have to choose this one, proxy SG, right? And then we have to save the rule. So this inbound rule has been updated with the two, then the proxy server, and one with the IP address, another with the another security group. So adjust which security group is attached to the proxy server 2 instance. Still, the Amazon EC2 console is navigation pane. Choose instance, see the proxy server instance, and then see the change security group. So which security group is attached to the proxy server 2? Now we are going to make a bigger perspective. So we have to see uh, which security group is attached to the proxy server 2. So we have to see instance proxy server 2, and then the security groups. Sorry, here in the security we can see that proxy SG2 is attached with that, right? Now we have to change the security group with it for this one. So for that we have to go to the actions, and here to the security there is change security group, and in here the change security group we have to add another security group, which is add security group proxy SG security group, and then we have to add proxy SG, right? So we have to select this group and then add security group, and then uh, we have to save it, right? So now another security group is added to this one. Proxy SG security group is added to this one, right? So let's see what next. test accessing the website from proxy server. Again, the same practice we have to perform from the both proxy servers and see that how it is behaving. So let's go to the instances, take the IP address of server IP, this one, and then details, and then copy IP address and try to access the app server. It is accessible, okay, fine. And what about the other one? Go to the proxy server 2 and then see that from this one, how it is behaving. Actually, it is also accessing. It was restricted, but from the big security group, proxy security group, now both are able to access the application server, right? So the task is completed until here. Now come to the task 6, which is restricting HTTP access by using network access control lists. So for that, uh, basically we will focus on ACL, access control groups are not the only method that we can use for the security access to the network port. So we will use ACLs to control access to the EC2 instances. So add a new inbound rule on the lab VPC network ACL to deny all inbound traffic on port 80. So we have to go to the VPC console, which is already open here, this one. And then we have to go navigation pane, choose the network ACLs, and in the network ACLs, we will see that select the network ACL that is associated with the lab VPC, and then we will modify inbound rules in the using the edit inbound rules. So for that, what we have to do, we have to go to the VPC. In here, there is network ACLs, right? So there are network ACLs available. There are inbound rule, 2 inbound rules, and then there's 6 subnets, and then there are 3 subnets are associated with that, right? So we can see here there is lab VPC, means that this ACL is associated with the lab VPC, this one, the down one, right? This is lab VPC one, right? Okay, come to the this one, and let's see that ACL that is associated with lab VPC, and then inbound rule, and we have to modify the rules. So associated with that, and then there is inbound rule, and there is all traffic, all access, and that is allow. In the security groups, basically the inbound and outbound rules only that are only for the allow. But here in the uh, ACLs, we have allow as well as deny rules, right? And you can see here the rule number. So we can give the number, and that actually define the priority of the rule. So let's see here what is edit inbound rule, add the new rule and enter 99, edit, add new rule 99. Then type is HTTP, allow, choose deny. Sorry, that is all traffic or what? Okay, HTTP, and then sorry, HTTP port is 0, and it is deny, right? We are denying the service, and then save changes. So we have created another rule that is having more priority, 99. So we have to check for the proxy server that either it is working or not. So actually we denied all the traffic. See here, deny. So it should not work actually. So let's check for it. Proxy server, and then go for this one and open the rule. it should not be able to access the app server, right? It is trying, but there is no. Then check for the second also, that will also be restricted. Now add another rule, and that will its number is 98, and the same, but it is with the allow. So the timeout, no response. Okay, come here, edit inbound rule, and then we create another rule that 98 http 0, and then that is allow and save changes. So if we can access the same, we should be able to access, right? So here we have identified another thing, that rule number 98, 99, and 100, the top priority is the minimum with the minimum number. Here that was allowed, but 99 was saying it was deny, and then 98 says it's allowed, so now it is working. Okay, so until here everything is going fine. Next thing is we have tested and everything is working very fine. So we have seen that ACL have rule number and rule number has priority. Rules are evaluated in order, starting with the lowest number rule. When the rule matches traffic, it's applied regardless of any higher number rule that might be contradicted, right? So it is working fine. Now come to the task number 7. So this task, we will begin to explore how we can connect to app server terminal. In this task, we will use SSH key. Basically, this is the terminal here. Here, we will be able to connect with the server. So in the EC2 console, choose instance and then select the proxy server 2 instance. Rename the proxy server EC2 instance. Uh, Okay, for that, before that, we have to perform some other things. For example, we already have one instance, proxy server 2 instance in our EC2. So we need to rename that with bastion. So let's go to the EC2. Here we have proxy server 2, and that we have to change the name to this one and then save it, right? Uh, Now we have this bastion server ready. Next thing, that is we have going to create a new security group with the name bastion security group, and in the description we have to add bastion sg. So for that we have to go to security groups, and then we have to create a new security group. The name is bastion sg, and description is also bastion sg. Sorry, here, and the VPC, by choosing this one, then choose lab VPC. Here we are going to use this lab VPC. Next thing, that is remove, and we have chosen this one lab VPC, and then we have to add some rules, inbound rules, and choose anywhere IPv4, and then security group, create the security group inbound rules. So for that we have add rule type SSH anywhere in the SSH, that is here, and anywhere before, right, will be allocated to that. So we'll be able to create we will be able to access this VM using the SSH, right? Okay, now let's create the security group. we are successfully created the bastion, and then we have group, bound rules. So actually, I'm verifying it that that is created or not. Inbound rule at rule. I'm not looking at here inbound rule. Okay, bastion SG and the outbound rule. Edit inbound rule. That actually created the outbound rule. So by default, it should be inbound rule, right? So we have to add this one also inbound rule, add rule. So SSH and then anywhere in the AP. So save rule, right? So we have inbound rule too. Okay. So now come to the next thing, that is update the Bastion host instance setting to use the Bastion SG. So we have to go to the instance, and then we have to change the security group. So in here, you see two instances, this one, select this one, already selected, then there is action, and then there is security, and then there is security, change security groups. In here, we have to connect it to Bastion. That is this one, Bastion SG, right? So add security group and save, right? And save. So we have added this Bastion group to this instance, right? So the security group is added. Now come to the other point, that is added the inbound rule for the service group uh, to allow traffic from Bastion host. So for that, we have Bastion private IP value. Since we also have from there, we can also use the same value. For example, we can use this private IP address value, and also we can see from here, this is proxy server 10.0.13, right? This is the same as that is given here. That is private IP addresses of the Bastion is 10.0.2.140, and here we can see that the Bastion private IP address is 10.2.0.2.140. So both can be accessed from here. Can be accessed from here, right? So close it, and went to the top. We are in the end of the lab. So anyways, so we have got this IP address, and uh, okay, Bastion private IP value got. In this Amazon EC2 console, navigate to the security group, and app server SG security group, inbound rule, app server security group, inbound rule. We have these rules, and then we have to edit rule, and we have to add the edit inbound rule, add rule, and then SSH custom slash 32 seeder, right? So only this IP will be allowed. Only this IP will be allowed. Seeder is another mathematical. So you have to focus on that. Okay, and then save the rule. We have to save. So now we have configured the security group, app server security group also to access uh, through that SSH or the private IP. Now come to the bastion host by using SSH in the terminal panel next to the here, that is we need to write SSH minus bash. So SSH minus add slash dot SSH slash lab labs user. Actually, there is one labs user dot pem. So we have to add this one and identity edit. So the labs user is added here. Next thing is we need to add this command SSH with and to try to access the public IP of the bastion. So we have to add that one for the public IP. We can go and we can find out from this way instance, and then in here that is the public IP. So we have to copy this one, 54.2.10.34, right? So we have to go here. That is here 52.210 uh, 34.40. Okay. Yeah, okay. Modified a bit. So SSH minus I, and then the address of the user, and then minus a ec2 dash user at the rate the IP address, public IP address. So let's see how it is behaving. That is TCP of the host can't be established. If the SA key fingerprint is this one, and yes, okay. The first time when you are going to log in, then successfully we access the system successfully, right? So when prompted, yes, everything is fine, it is connected. uh, Connect to the app server through SSH by following the authenticated connection. Run the following command replace applications server private IP with application server private IP, right? And which you can find by using this one application server. So let's try to connect with this user app server private IP. So that is here app server private IP is, we are going to connect this one. Then there is a private IP only, that is 10.0.11.15. 10.0 10.0.11.15, I guess, right? 15. So now try to access that it is accessible from the private IP or not. So yes, it is also connected to the app server, right? Now we have to create a new file to approve that we are connected to the app server instance. So we can use touch command for creating the file touch, and then a new file xt. So this is the editor, right? So the file is created successfully. Now we are able to access the app server using the bastion SSH connector, right? In the terminal, to disconnect from the app server, run the exit command, or so will be exit from the system, right? So exit exit, so connect is closed. To disconnect from the bastion server, we have to run the exit again. So we are disconnecting from the server also. So we also disconnected everything. Uh, so we have identified that we can connect to the app server using the SSH connection also. Uh, and obviously we were able to access because of the security groups we configured, right? So now come to the task number 8, connecting directly to a host in a private subnet by using session manager. So the task is what should you do if you need to modify configuration setting for your application server. So what we can do, instances are located in the AWS cloud, so you can use the system manager session manager to connect directly to an instance used without opening port 32 for the SSH or connection through the another server and the public subnet list. For this work, the session manager agent must be installed on the target host. So Amazon Linux EC2 instances that are already we and through which we can connect to the system. So using a bastion host is the best practice in the VPC network, but using session manager can be an alternative also, right? So putty is also another one. Might be you heard the name. So the Microsoft we can use the putty for the session creation and all, right? So you can see and explore this one. So this is gives you ability to use AWS identity and access management to grant access to users and create an auditable logging trail, and we can observe using the cloud watch and cloud trail later on also, that who is going to access which resources and all. So for that, for the user internet, and then we are going access the so by using the session manager, we are going to access the VPC, and then we can go and consider we are going to access the uh, instances that are in the private subnet. So for that, connect to the app server by using session manager. This is another layer. So we have to go for the Amazon EC2 instances and select the app server and choose connect to the we have to go with respect to the session managers. For this, we have to go to the instance, and then we have to go to the app server. We are going to select, and then we are go to connect and session manager, choose connect. So from here, connect, and then we have EC2 instance connect, and then there is session manager, and then there is connect. So we are going to connect this one, and after that session is going to be established. So we have seen this black screen that is also visible here. So to modify the website hosted on this server, run the following command. Actually, we are going to change the text that was previously that was visible. Now we want to change it. So let's see it is editable or not, but I don't think so. Paste. So session manager was used to edit this file. Previously, there was one message regarding that it was connected, but now we are amending that file, this index.html with more text. So we are going to connect with the session and then we are amending the file, we are modifying the file. So the command, definitely we are going to run the command, so the command is executed. So after that we are going to verify it, proxy server IP address from proxy server 1 IP address. So for that we are going to public IP address, copy this one and then try to open it here. So we will be able to see that this session manager was used to edit this file, right? uh, we have modified the app server using the command line session. So we have successfully connected to the instance that is located in the private subnet as subnet and modified a file on the instance securely. By using this approach, we can avoid many detailed configuration steps that were required to use a bastion host to connect. So there are many ways we have already studied the security group, the ACLs, then the bastion, and the fourth one that is using the session creation and all. So we have successfully completed all the steps. It's time to submit the task. So submit. Yes, we are going to, are you sure we are going to submit? It's for the hectic submission is recorded. The submission report is going to be created and the grading is also in the process. So wait for a while.